Page 2, exam review. Picks up with actually the bottom of page 1 with question 9, that using electron configuration, you look at the last item, 3p4, and you go to that location on the periodic table, which is in the third row, go over to the P section and count over 4 spots, and you land on sulfur to identify the element. So in question 10, when you have the shorthand notation referencing krypton and then 5s1, you go to the 5th row, the S section, and the first one in would identify that element as rubidium. For question 11, writing your shorthand notation for cobalt, you would fill up all of the S, P, D, and F sections until you got to cobalt, and you'd stop at cobalt, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then there should be 3d7. So make that correction on number 11. Instead of it stopping at 4s7, that should be 4s2 and then 3d7 after that. Question 12, which ones would have the same electron configuration? Well, that's going to have to be an element that is an ion that either loses or gains enough electron to become just like a noble gas. So the only two that match up to become the same electron configuration would be sodium that gives up one valence electron to fall back to being 2p6 full orbital of 8 electrons in that S and that P on the second orbital. So the electron configuration looks just like neon. And then when you do neon's electron configuration, you see that it ends at 2p6. So it is identical to sodium plus 1 ion. Whereas the other ion of potassium and bromine do not end up looking the same, because potassium plus 1 bromine, potassium plus 1 ion, when you lose 4s1, would fall back to stop and look at 3p6. But bromine negative 1 ion would gain 1 more electron in its 4p5 plus 1 more to become 4p6. So those are two different noble gases that potassium plus 1 ion becomes when you compare it to bromine negative 1 ion. Question 13. It's asking for the number of electrons in bromine. Well, they gave you extra information there. They told you the mass of bromine by doing the bromine dash and that mass value, and that it had 45 protons. Well, that has nothing to do with neutrons. Go to bromine on the periodic table. Get the atomic number. 35, that is the number of electrons. It's not an ion, so you don't have to add or subtract any electrons to get the number of electrons in that question. Number 14. Number 14 is an ion, and it gives you that calcium is a plus 3 ion. So that means you've got to take away 3 electrons from the number of its atomic number, which is already given to you as the 20 on the bottom of that shorthand notation. So it's 20 minus those 3 electrons that calcium is saying it's given up to become 17 electrons. And I think I misread that. The print was so small. Calcium should be giving up 2 electrons, so that really should be 18 electrons that calcium actually has, 20 minus 2. Sorry about that. I misread it. So going on to question 15, though. What do the dots represent on the Lewis dot structures? Those are the valence electrons. Count the tall columns over to find your element, and that's your number of valence dots that should be around any symbol. Question 16 asks you to write the formulas for sodium carbonate, sodium bicarbonate, and calcium phosphate. Those are going to require you to look up their charges and cross mode to get them as a subscript. Question 17 is asking you to name these compounds, draw their Lewis dot structures, and then also name the shape for the Vesper shape. So you will get to use the chart for the Vesper shapes for own level. Pre-AP, you need to know your shapes and chart. So with phosphorus trifluoride, you should have phosphorus in the middle, 5 valence electrons. 3 fluorines around it, because it tells you there's 3 fluorines. Trifluoride means 3 fluorines. And they have 7 valence electrons. So there's a sharing of the valence electrons between the single electron that's on fluorine and the single electron to the center on phosphorus, on each of those bonds going in on the single line drawn between fluorine and phosphorus. And so the shape of that one, since it has a lone pair of electrons, that shape will force it to be trigonal pyramid. Then on the next problem, where it's H2O, it has dihydrogens, that means there's 2 hydrogens that needs to be drawn, and 1 oxygen in the center. Oxygen has 6 valence electrons, so the single electron that's on the left and right will be shared with the single electron that hydrogen has, and because water has 2 unshared pairs of electrons, the shape becomes bent for the drawing. Then the last compound, silicone disulfide, means you have 1 silicone in the center with 6 valence electrons, and di means you have 2 sulfurs on the outsides, right and left. So there'll be a sharing of a pair of electrons for a double bond between each sulfur going back to the silicone, so this shape can only be linear in its type of shape to name its Vesper shape.